Okay, so problem 4. Now, problem 4 here, we always start with the inflection point. So let's start by figuring out what the shift is going to be. So inside this parentheses here, you have a -1 or -1. So which way are we shifting? Well, we're shifting right. Anytime you have a negative inside, it's going to be shifting right, 1 unit in this case. And we have a -2 on the outside, so this tells us our vertical shift. Whenever it's a minus sign on the outside, we're going down. So down 2. Down 2. So using this shift, we always start the origin. So I'm going right 1, and then I'm going down 2. So here's my inflection point. So I'm going to plot that on here. There we go. We have our inflection point, and it looks like we're at 1, +1, and -2. So I have my coordinate, and now let's find what the other 2 points are going to be, because we need 3 points total. So remember, we can always grab the slope in front of our x. But here's the deal. So whenever you're trying to use the slope to graph your cubic, you can only be 1 unit away from the, when you plot the other 2 points, only 1 unit away for accuracy. Because once you go further off, because I will warn you, once you go further off from the inflection and you try to use the slope as to help you plot the points, it doesn't work. In other words, your values are not going to be correct. So how do we kind of avoid this? Well, you have to be 1 unit away from your inflection point. So what you do is you take your slope. So my slope here is 1/2, right? So 1/2 as my slope. Well, what is 1/2 as a decimal? Well, that's 1 divided by 2, which is 0.5. So in this case, my slope is 0.5. And what I want to do, if I want to make this 1 unit away from my inflection point, is that I want to make my run 1. So that means that I would have to go to the right 1 unit, or in other words, the x. I would have to go 1 unit. So I make this over 1. So basically what I do is I take the fraction, find the decimal value for it. So 1 divided by 2 gives me 0.5. And then I put that value over 1, because that means I'm only going to the right of the inflection point 1 unit. And so that allows me to have an accurate point. So this is saying 0.5. In other words, my rise is going up 0.5. So that's up 0.5 and then over 1. So here's my point that I want to plot. I'm going to grab my pen and plot that point. And then if I want the other point, then I have to go down. I have to go in the opposite direction. So down 0.5 and over to the left 1. So here's my point. So I'm going to plot that as my third point. And then I'm going to connect the dots. So it looks like it's going down first and then up. So I draw my cubic function. And there we have it. We have our graph. So now let's find our y-intercept. Remember, y-intercept, your x value is always 0. So x is 0. We're going to plug in this 0 for x in this equation and find our y. So setting that up here, we have 1/2 0 minus 1 cubed minus 2. So if I work this out, remember PEMDAS. So I want to work inside my parentheses first. So 0 minus 1 is going to give me -1. 0 minus 1 gives me -1 cubed. This 1/2 outside, -2. -1 cubed, so exponents is next. If I take -1 and I multiply it 3 times together, that's going to give me also a -1. I still have this 1/2 out here. -2. So I'm going to shrink this down a little so I can move it. So it looks like I have -1 times half, which gives me -1/2. 1/2, or 1 over 2 minus 2. And so if I put this in my calculator, negative 1/2 over 2, that's just negative 0.5 minus 2. So that is going to be negative 0.5 minus 2, which is negative 2.5. So I'm just going to keep it as a decimal. So my y value in this case is negative 2.5. So I'm going to write that here. Negative 2.5. Okay, domain and range, if you remember from the last video, all domain and range are all real numbers. And if you need to know why that's the case, watch the first video, problem 1, and I explained why that's the case. Okay, that's it.